All right, guys, more on systems of linear equations and matrices. So this is one of the types of videos that students typically seem to like because no new stuff, just going to work through problems and just tell you things to think about. These problems that we're going to look at today are going to, or at least in this video, are going to look a lot like what you have to do on my math lab on your assignment, your online assignment, and what you'll have on your exam and final exam. So let's get after it, okay? As I've talked about before, these types of problems, once you read them and realize that you've got something that's setting up like a systems of linear equation problem. In other words, you've got information on multiple things. I always go to the last sentence, and this tells you where your variables are going to be set up, or at least how your variables are going to be set up. So it says how much should how much should the investor put in each type of bond to have an interest income of $2,000. So what I need to do now, I realize that I'm talking about the type of bonds, so I need to go back now and read the problem very carefully and see what kind of bonds are presented, what information is presented about what type of bonds in the problem. Well, I see that an investor wants to invest $30,000 in corporate bonds that are rated AAA, single A, and B. So it automatically tells me I have three types of bonds. So I'm just going to let X be the amount in the AA bonds. I'm going to let Y be the amount in the A bonds. And I'm going to let Z be the amount in the B bonds. So now from this, what I know is I have three variables. So I have to be on the lookout for three equations. Okay? Well, the first one's, at least in my opinion, we know that this investor wants to invest a total of $30,000. So the amount here plus the amount here plus the amount here has to be $30,000. So let me get this straight here. So the X plus Y plus Z has to be equal to the $30,000. The other information I've given in the problem is that the interest has to be $2,000. Well, we know that we find interest by taking the amount times the interest rate. Well, the average yield is 5% on the AAA, so the amount I have in AAA, which is X, times 0.05 will be the interest that I get from that particular investment. The next thing I see is see that, typo. I think this was 6%. So, guys, I left something out there, so I'm pretty sure that's a 6%. So let's see. The answer may come out wacky, but we'll use 6% there. I'm pretty sure that's what it was. And then the 10% on B bonds. So, guys, 10% on the amount in B bonds. So the interest from the AAA plus the interest in the single A plus the interest in the B has to be equal to the total interest of $2,000. But I'm not done yet. Still got just three equations. I need to find another one. So I have to look into the wording of the problem, see if I can find anything else that they have. So I see there's this sentence here that says, being conservative, the investor wants to have twice as much in the AA bonds as in the B bonds. Now, it is so tempting. Can you guys even see that? Nope. It is tempting to do this. It's tempting to say twice as much in the AA. We know AA is X, as there is in the B, and we know that the B is Z. That's so tempting. But let's think what happens there. If I have in the the AAA, AA is actually a highway. If I have $2,000 in the AAA and the Z is B, and let's say I have 1,000 there, then I have double in the AAA that I've got in the B bond, okay? So when I put this and multiply this by 2, I get 4,000, which doesn't equal 1,000. So guys, it's tempting to do this and it's completely wrong. When you're trying to make two things equal, you have to multiply the smaller amount to make them equal. So if I've got twice as much in the AAA that I got in the B, then I'm going to have to multiply the smaller amount by 2 to make those two things equal. So what I would need here is I would need 2 times Z to be equal to X to make those two things equal. It's a common misunderstanding, a common mistake, and I'm ultimately going to find out the people who have watched the video and who didn't, based on this alone. If you got twice as much in the AAA that you've got in the B, you've got to multiply the smaller by 2 to make them equal. Okay, so just keep that in mind. Now the next thing I've got to do is I've got to notice that I've got to get this into a form where I can use augmented matrices. So I have X plus Y plus Z is equal to 30,000. That one's easy. And the 0.05X plus 0.06Y plus 0.10Z equals 2,000. That's easy. But gang, this one right here isn't in the form that I need of my X's, my Y's, my Z's, and my numbers. So I got to bring this X across, make it negative X. And then my 2Z has to be below the Z entries. And then I got nothing over there, so I just have to put equal to 0. So guys, my augmented matrix here is going to be 1, 1, 1, 30,000. And 0.05, 0.06, 0.10, 2,000. And then negative 1, 0, 2, 0 to make this happen. So guys, when I do my reduced row echelon form, I'm going to get the form, as we've seen in previous videos. So the number that I get right there will be the amount for X, the amount that I get right there will be for Y, and the amount that I get right there will be for Z. So this will be my triple A's, this will be my A's, and this will be my B's. So gang, what I'm going to do is I'm going to get out of here. I'm going to go over and grab the calculator. So I'll go to second function matrix, go over to edit. I'm just going to use matrix A. So gang, it needs to be a 3 by 4. Okay, so just type very carefully. I hope that was 0.06. I'm starting to guess if it was or not. Seems like it was 0.075, so this may not even work out. We'll see. Alright, if you type slower than me, that's fine. So negative 1, just pause me. 0 and 2 and 0. Alright gang, second function quit, so get out of that. Let's go back and get it. So go back to matrix and go over to math. And it's closer to the bottom than it is the top, so I'll scroll down. Go back into matrix and grab the matrix that you want to perform this operation on. Close it up. And it turns out that we get an answer of 20,000 for the A. So we're going to have a 20,000 that goes into the AAA. We're going to have no money in the single A, and we'll have 10,000 in the other. So these are the numbers that were on the last. So does it meet all of the criteria? Well, it's clearly 20,000 plus 10,000 gives us 30,000. And we have 5%, so this gives us $1,000 there, and this is 10%, gives us 1,000 there, so there's 2,000 in interest. And sure enough, the amount we have in the AAA is double what we have in the B. So again, I'd have to multiply this by 2, going back to this thing right here, to make those equal. So, guys, that's a situation that pops up a lot in 1700, where you want to have certain conditions where you have more money in maybe one fund than the other, because maybe something has more risk. All right, guys, let's take a look at this one. And the first thing I'd want to do is, again, learn from the past. And on these types of problems, what we have is we have the quantity as a function of the price. So what I want to do for the supply equation is I want to set up the 2 ordered pairs that I have. So I know that when we have a supply of $8.50, we have a cost of $1.50. I'm sorry, $1.40. And then we come down and look for the supply. When the price falls to $1.20, the daily supply decreases to $3.50. But we're working at a price of $1.20. I like to circle these so I know what I've used. Just kind of helps a little bit. So guys, you can do this a couple of different ways. If you like to pound this out and do it by hand, find the slope, the intercept, that's perfectly fine. I just prefer to use the calculator because it works. So guys, I've got some information there, so I'll go up and highlight and I'll clear enter, so get rid of that. Then I want to come over and clear out L2 as well and go clear enter as well. So let's put in our order pairs of 850 is one X and 350 is the other X. And the order pairs, the Y values would be $1.40 and $1.20. All right, so second function quit, go stat, go over to calc, come down to number 4. So we have L1, L2, what we want, and go calculate. So what we got there, we've got a situation where we're given something in scientific notation. Now this 4e negative 4, let me go back over here and show you what that means. The 4e negative 4 says that we need to start with the decimal place where it's naturally, when we have a 4. The negative says we have to move this 1 place, 2 places, 3 places, 4 places to the left. So we always have to fill in with 1 less 0 than the number that we have right there. Because it's 1 less, because the first number takes us past the 4 or the 2 or the 3, the non-zero number. So guys, we know here that Y can be given as 0.004x, and let me go back, plus 1.06. Now, technically, what you got here is our Y's are our price, our X's are our Q. So really, however you want to look at this, if you want to use the original variables of the problem, fine. But X's and Y's, as long as you know what they are, work just fine too. Now, for some reason I switched from black to blue, and actually I think the blue actually shows up better, so I think I'll keep that. Now, guys, for the demand, we're going to see that the 580 is the demand when we have $1.40, and 980 is the demand when we have $1.20. So I'm going to go back to calculator, go back to stat, go to edit. Now guys, the only thing I need to do is change the first 2 numbers, change the 850 to 580. and change the 350 to 980. All right, so let's just go second function quit. Go back into stat, go over to calc, come down to number 4, and we're using the same list, so there's no difference. And what we got here is we got negative 5e to the negative 4, but for the same reason I explained earlier, this is going to be y equal negative point, put in 3 zeros. Don't forget your x, because you have to have a variable. All right, so I'm writing this down so we can go back over and take a look at it. So again, the equivalent of this using the is we can predict the price at the, for a certain amount of quantity. And we get this right here. Okay? Now, regardless which way we use, whether it's y's or x's, we can see that we can take, that was my phone by the way, everybody's looking for their phone, what's going on? We can take the first relationship, and I'm just going to use the y's and x's, and then we can take the second relationship, but the instructions here tell you to use the easiest way, which is the augmented matrix. Well, to do that from previous problems, I know I need to have my, my x's in the first column, my y's in the second column, and my numbers to the right of the equal sign. So to do that, I'm going to bring this 0.004x across. The y's already over there. And the 1.06 stayed on the right side of the equal sign, so its sign doesn't change. Negative 0.0005x comes over. Now, I'm not even going to get into the augmented matrix here. I'm going to assume that you guys already know how to do that because this is about the 15th problem we've done here. But I'm going to, I'm going to demonstrate it, but I'm not going to write it out. So, going to matrix, I want to go over to edit. Looks like I'm going to need a 2 by 3. So I have negative 0.0004. Make sure you get the right number of zeros in there. 1. And 1.06. All right, gang, next one, negative 0.005, 1, and 1.69. Sometimes people get sloppy with this stuff, and they'll, they just make typos and. Well, guys, I've lost my mind. You guys are probably sitting there screaming at me. What have I done? Talk about getting sloppy. I wish I could tell you I did that on purpose, but I didn't. I just did it because I'm a bozo. No, that's right. That's right. No, because we bring this across, so it makes it a negative, and we bring this across, so it makes it a positive. So, guys, I'm losing my mind. Hopefully you guys knew that, because I'm sitting here just talking gibberish. You're probably sitting there thinking, I'm confused. How did that negative change to a positive with that? All right, gang. So we got matrix A, so I'm just going to go second function quit, because I know somewhere previously I've done that. That wasn't it. That wasn't it. That was it. And I just hit enter. So, guys, what we got here is we've got the solution 700 1.34. So I wrote that down there. Now what you got to realize is this first entry stood for what? X. So in this problem, X was our quantity. So 700 was our quantity, and this line right here stood for our y's, and our y's in this situation was our price. So the equilibrium quantity is 700 units, and the price was $1.34. Okay, that's going to be the easiest way by far to find a equilibrium price. All right, gang, write a system of linear equations without matrices and solve. Well, what we do here is we go back to what we know about multiplying matrices. So when we have a 3 by 3, and here we have a 3 by 1, these two numbers have to be the same there, and they will create a 3 by 1 matrix. And you multiply these things by taking the corresponding rows with the corresponding columns. So what you can see here is you take 2 times x1 plus -1 times x2 plus 0 times x3, and it will be equal to this number. So guys, the first equals 6. That's 0 right there. So 0 times x3 gives us 0, so we don't have an x3 term in that equation. So -2x1 plus 3x2 minus x3 equal -4. And here we get 4x1 plus 0x2 plus 3x3 equals +7. Now guys, if I'm going to solve this, I'm going to use the augmented matrix for this. And that's really easy to get from this part right up here. The augmented matrix is really just kind of smashing all that together without the x1, x2, x3, without the variable column vector here. So I'm going to have 2, -1, 0, 6, -2, 3, -1, -4, and 4, 0, 3, +7. So let's go put that in our calculator. So matrix, guys, we should be really good at this. So this is going to be a 3 by 4. All right, so 2, -1, 0, 6, -2, 3, -1, -4, 4, 0, 3, 7. All right, so let's get out of there. Second function entry, because we just did it. And we said that the answers here will be x1 is going to be 3.0625. x2 is going to be equal to 0.125. And x3 is going to be equal to -1.75. So guys, the solutions that we have, I don't know why I did that, will be right here. Okay, so exactly what we've been doing previously. It's just presented to you in a little bit different term, or a little different form. Now, I gave this problem, and you've got one of these on my math lab, and this absolutely, well, shoot. All right, guys, I didn't. For some reason, the numbers didn't come through. So, guys, hold on. Let me go get my textbook. Alright, I found the textbook. Let me get through here and see if I can find the problem. I don't know if I can or not. Okay, linear inequalities. Shoot. Shoot. Okay, here it is. That's actually easier than I thought it would be. So car frames, 10.8, so 3,000. 2,800. 2,600. 1,600. 2,000. And 2,200. All right, now I'll tell you a story. I gave this problem to a previous class, and they were in the computer lab. They were in the math lab, and I walked by, and they're like, Dr. Darber, we don't know how to do that one. And when I selected that, I actually tried to set it up where it would be a multiplication problem, where we would multiply the matrices. Because it looked like what would happen here, let's just call this matrix A and matrix B. Where matrix A, we have our plants A and B, and we have our car frames and our truck frames. And then when we multiply here, we have our car frames and our truck frames, and then we have our orders 1, 2, 3. Well, if you've been paying attention at all, when we multiply matrices, you know that we need not only this number to be the same as this number, but we need to measure them to measure the same thing. And they do, which would create a matrix with A and B on the rows that always comes from the first matrix, and the columns from the second matrix, because the columns from the second matrix always create the columns of the product matrix. But what we end up with there is orders, right? Not hours. So how many hours should be scheduled at each plant to exactly fill each of the orders? So guys, what we have to do is we have to look at these problems independently of the other one. So although I set it up to work like this, when I sit down and help the people in the math lab work the problem, I realized, well, this isn't a multiplication problem like I thought. It is just a system of linear equations problem. So guys, the first one for order number 1, we know that from plant A, we have 10 car frames. And what I'm going to do up here, I'm going to change from plant A and plant B. I'm just going to call those X's and Y's. Okay. So I'm going to have this as 10X plus. No, wait a minute. Let me think about this for a second. So how many hours should be scheduled at each plant to operate to exactly fill each of the orders in the following table? So the supplier for the automobile industry, car and truck frames at 2 different plants, the production rates in frames per hour for each is given. Okay, so that's not right. What we got is we're going to have to let our car frames and our truck frames be X and Y. Because at plant A, okay, I'm confused. Well, no. We have car frames. Okay, I see what's going on. We have car frames that have to be equal to 3,000. So the only way that we can get car frames is to add the car frames from plant A and the car frames from plant B to get the total number of car frames. The total truck frames from A plus the total truck frames from B has to be the total truck frames. So I was right in that the plants have to be X and Y or A and B. So guys, I need the 10 car frames per hour for plant A plus the 8 from plant B So car frames plus car frames is going to be equal to car frames. And then truck frames plus truck frames has to be equal to truck frames. So what I'm going to do is I'm actually going to work three problems here for each order. So I'm going to go ahead and work order number one. So guys, I'll show you how to do that. So let's go into Matrix. Go to Edit. Guys, we got a 2x3 here. So 10, 8, 3000, and 5, 8, 1600. Guys, second function quit. We've got the RREF command, so all I got to do is just get it. Hit enter, and I can see that I need 280 let's see how many hours. So I need 280 hours from plant A, and I need what, 25 hours from plant B. Okay? Yeah. Now, I just do the same thing for the other problem. So instead of having 3,000, I would have 2,800 and 1,600. I would have 2,000. All right, so this is going to be one of those problems. You've got one exactly like this on my math lab. So if I start getting emails about this problem, I'm going to be able to isolate the people who aren't watching the videos. And that's not cool. All right, guys, solve the system. We should all know by now that this is easy. All we have to do is get everything in line. So I'm just going to do a little bit of mental arithmetic here. Now, see, I have 0.04x, 0.05y, 0.06z, 360, 0.04x, 0.05y. I see that this 0.04 is on the wrong side, but the 120 is on the right side. X is on the right, well, the correct side, left side. The y needs to come over. The negative z needs to come over. And that negative 7,000 needs to go over and go like this. So, gang, let's just, you know, again, like we did before. So we got 3x4. So 0.04. 0.05, 0.06, 360, 0.04, 0.05. I say this not to bore you to death, but just so if you are typing, you don't have to keep looking at your paper. So negative 0.04, 120, and the last one is a bunch of ones. Except for the last entry. And the last entry is 7,000. Okay. So, gang, go second function quit. We've got the RREFA right there. Solve it. And our solution would be x equal 1,400. Y is equal to 3,200. And z is equal to 2,400. So guys, that's the end. That's all the videos that you're going to have. Let me go back over here. All the videos you're going to have on systems of linear equations and matrices, other than when we get to the study guide for the midterm and the final. We'll have more stuff then. But what's next is something called linear programming. And now I'm going to tell you what I did. I put up some linear programming videos for previous classes, and I'm probably just going to reuse some of those. So if there's any reference in there to maybe it being you know, January or February or something like that, I haven't lost my mind. I know it's not. I know it's not that month, but I think they're good videos, and I don't see any reason to sit here for 2 hours and redo them. So, gang, have a great one. It's the end of this video.